Today we're working on your test review, your final test review of the semester. So we're going to start it off with simplifying square roots. Lots of ways you can do this. I'm going to show you one way. So the way that I do this is I break this down. So two numbers that multiply to 50, 5 and 10. Whenever you get to a prime number, you stop. So I'm just breaking down each of these numbers into two factors. Then once you do that, you can rewrite your original quadratic using those factors, those prime numbers that you came up with, and any pairs of those numbers goes on the outside. So 5 square root 2 is your final answer. And you can actually plug in 5 square root 2 to your calculator, and it should give you the same thing that the square root of 50 gives you. Very similar process over here on number 2. The only difference is there's a negative under the square root, so I'm going to put an I on the outside and make it positive. Breaking down 8, 2 is prime. Breaking down 4 into two numbers. So I've broken everything down, so rewriting the problem, I have I square root 2 times 2 times 2. There's a pair of 2's, so I bring that out with the I, and one of the 2's stays under. Moving on to target 2. So on target 2, we're using the square root method to solve our quadratic. So our goal here is to get our variable by itself, and then we're going to take the square root. So on this first one, I'm going to start by subtracting 9 on both sides. So I get 4x squared equals 88. Divide both sides by 4. I get x squared equals 22. So to solve, I take the square root. 22 is not a perfect square, and if I try to break it down, I can only break it down into 2 and 11, both of which are prime. There are no pairs like we talked about in target 1. So we just represent our final answer as x equals plus or minus, don't forget that, square root of 22 since we can't simplify it. Very similar process over here on number 4. I'm going to add 9 to both sides. So that's going to give me 7p squared equals 112. And 112 divided by 7 is 16. So I get p squared equals 16. To get rid of the squared, I take the square root. And this one actually is a perfect square, so I don't need to simplify it. It's just plus or minus 4. You can plug your answer back in to your variable in the original problem if you'd like to check your work. Same process, different problem. Subtract 5, so I get 3x squared equals 15. Dividing by 3, so I get x squared equals 5. And to get rid of the squared, I can take the square root. 5 is not a perfect square, and I know it's not going to simplify because it's a prime number. So I just say plus or minus the square root of 5. On this one, just because it's in a little bit of a different order, don't let that confuse you. I'm going to start by adding 8, so negative 10x squared equals, that would be negative 200. And if I divide both sides by negative 10, I get x squared equals positive 20. 20 is not a perfect square, but it does simplify. So I could say that multiplies, or 4 and 5 multiply to it. 4 breaks down into 2 and 2. So if you look here, I have a pair of 2's. So my final answer is going to be plus or minus. The 2 goes on the outside because there's a pair. The 5 stays under because there's not a pair. Lots of things to think about in these problems. All right, so targets 3 and 4 are paired up, so we are going to find the discriminant first, talk about that, and then we're going to continue solving with the quadratic formula. So first of all, I'm going to go ahead and label what A, B, and C are. And then the discriminant, if you remember, is what's under the square root, so b squared minus 4ac. So that's negative 6 squared minus 4 times 1 times 9. And that would be 36 minus 36, which is 0. If you get a discriminant of 0, that means that there is one real solution. And we'll circle back to that to see if that's actually the case. It should be. So then we're going to do the entire quadratic formula and finish solving. So we have x equals negative b, which would be positive 6, plus or minus the square root of the discriminant, all over 2 times a, which would just be 2. So the square root of 0 is just 0. And so you have 6 plus 0 or 6 minus 0. In either case would just give you 6 over 2, which simplifies to 3. So if you go back up to what your discriminant gave you, one real solution, we got one answer and there's no i's in it, so it matches up there. So two-part question here. Same thing over here on 8. A is 4, B is 4, C is 10. We're going to start off by doing the discriminant, b squared minus 4ac. Make sure you have this and the quadratic formula on your reference sheet. And then that would be 4 squared minus 4 times 10, just filling in those values. So 4 squared minus 4 times 10 is negative 144. So because this is a negative number, that means we're going to get two imaginary solutions. So in the end, we should have two answers, which comes from the plus and minus, and I should be in our answer. So let's fill in the quadratic formula. X equals negative b, which would be negative 4, plus or minus the square root of the discriminant over 2 times a, so over 8. So your first step in simplifying is to simplify your square root. So the square root of negative 144, well, 144, that square root is just 12. But now we have a negative under the square root, so our answer is going to be 12i. So we have negative 4 plus or minus 12i over 8. And then we can go a little bit further here and simplify because all those numbers are divisible by 2. So I'm going to go ahead and divide them all by 2. And then going back to what our discriminant told us, we were supposed to get two imaginary solutions. We did, because there's the plus and minus, and I is in our answer. Continuing with the quadratic formula, so just some different examples here. So A is 2, B is 9, and C is 6. So starting off with the discriminant, b squared minus 4ac. So that would be 9 squared minus 4 times 2 times 6. And that gives me 33. So since this is a positive discriminant, that means there's two real solutions. And we're going to circle back to that at the end to make sure that's the case. So filling in the quadratic formula, x equals negative b, so negative 9, plus or minus the square root of the discriminant, all over 2 times a, which would be 4. So next step is to simplify the square root. So I'm going to take it over here. And 33 only breaks down into 3 and 11. There's no pairs. So we actually can't simplify that. And then if we think about simplifying the fraction, those numbers are not divisible by the same thing other than 1. So that would be our final answer. There's no simplification we can do. Last one for quadratic formula, but same process. So we're going to start with the discriminant. And it will be paired up like this on your test. You will be asked for the discriminant first, and then you'll go ahead and solve. So 2 squared minus 4 times 4 times negative 30. So we get 484. And that means we're going to get two real solutions because it's positive. That's something you want to make sure you have on the reference sheet as well. Just what does that mean if it's positive, negative, or 0? So let's fill in the quadratic formula. X equals negative b, so negative 2, plus or minus the square root of 484, divided by 2a, which would be 8. So on this one, 484 is actually a perfect square, so I'm going to rewrite it as 22, because the square root of 484 is 22. And then I can continue simplifying because there's no square roots. So for my answers, I'm going to start off with negative 2 minus 22, which is negative 24, divided by 8 is negative 3. That's one of my answers. Now I'm going to do negative 2 plus 22, which is 20, divided by 8. 20 divided by 8 would simplify to 5 over 2. So I'm going to go ahead and simplify it all the way. And then going back to my discriminant, told me 2 real solutions. I got 2 different answers, no I, so everything is matching up. Moving on to completing the square. Your first step in complete the square is to subtract the constant to the other side. So now I have n squared minus 16n equals negative 48. And then we're going to take half of our middle term, so half of negative 16 would be negative 8, and then square it. So 8 squared is 64. And that's what you add to both sides. So now we're going to write our complete the square form. So remember, you take half of your middle term, so that's why it's n minus 8 squared equals, and we have negative 48 plus 64, which is 16. Now we're going back to square rooting. So I have n minus 8, the square root of 16, that's a perfect square, so I get plus or minus 4. And then I'm going to add the 8 over. So I'm going to do positive 4 plus 8, which is 12. I'm also going to do negative 4 plus 8, which is 4. And those are my 2 answers. So on number 12, we're going to start by subtracting the 29. So we have a squared plus 12a. I'm going to leave a little room here. Equals negative 29. So half of 12 is 6. 6 squared is 36. Now we're going to write the complete the square form. So like I just said, half of 12 is 6. So this will be a plus 6 squared, and this equals 7. Square root both sides. A plus 6 equals, 7 is not a perfect square, it's also prime, so it can't be simplified any more than that. Make sure you do the plus and minus. And then we're going to subtract the 6 over. We can't actually combine those values because one has a square root and one doesn't, so that will be my final answer. On number 13, I'm going to add 32 to both sides. So we have m squared minus 4m, and on that side now we have 32. So half of the middle term would be negative 2. Negative 2 squared is 4. So now we're going to write the complete the square form. So like I just said, half of negative 4 is negative 2, so it's m minus 2 squared equals 36. Taking the square root. So we have m minus 2 equals plus or minus 6, because that's a perfect square. Add 2. So we have positive 6 plus 2, which is 8, but we also have negative 6 plus 2, which is negative 4. And then on the last one for complete the square, starting the same way, I'm going to add 60 to both sides. So we have x squared minus 12x equals 60. And then I'm going to take half of the middle term. Half of the middle term is negative 6. Squared is 36. So then putting this in complete the square form, half of the middle term was negative 6. That's why that's there. And then this would be 96. This next step, 96 is not a perfect square, but I do feel like it's probably something we could simplify. So you can always take it over to the side if you think you can simplify it and need some room. So we could break this down into 48 and 2. 48, I think 6 and 8. 6 breaks down into 3 and 2. 8 breaks down into 4 and 2. 4 breaks down into 2 and 2. So quite a bit going on here. So let's take a look here. So it looks like we have two pairs of 2 and a 3 and a 2 left under. So if we have 2 pairs of 2, 2 times 2 is 4. And then we have a 3 and a 2 left under, so 6 is left under if you multiply those. Adding the 6 over, we can't combine those, so it's 6 plus or minus 4 square root 6. All right, moving on to some factoring. So first thing we always look for is a greatest common factor. I'm not seeing one on this first example, so let's go ahead and go into our factoring process. So we want numbers that multiply to give us a times c, which would be 126, and that add to give us our middle number, which is negative 23. So I'm going to take a moment and just try to figure out what those numbers would be. So I think we could have negative 14 and negative 9. So we're going to rewrite our quadratic. So 2n squared minus 14n minus 9n. Notice I didn't take the shortcut here because a was not 1. Grouping, look for a common factor. The common factor is 2n, leaving me with n minus 7. The common factor over here is going to be negative 9, leaving me with n minus 7, which means I did this right because n minus 7 is the same, and the other factor will come from those two GCFs in the previous step, 2n and minus 9. So that's the first part of our answer. And then we'd set these equal to 0 and solve. So I would get n equals 7, and if I set this equal to 0 and solved, I'd get n equals 9 over 2. So I'm going to actually box in both of those because both of those are important pieces of your final answer. All right, I think we have a common factor over here of 5. So if I take out a 5, that would leave me with 7a squared plus 36a plus 5. So I'm looking for numbers that multiply to give me 35 and add to give me 36. So 35 and 1 would work. So I'm going to rewrite my quadratic. So 5, and I have 7a squared plus 35a plus 1a plus 5. And then I'm going to take a moment and go ahead and group the first and the last two. First two and last two. And then I'm going to look for a common factor. So the common factor in the first group is 7a, leaving me with a plus 5. In the last group, it would just be a 1, again leaving me with a plus 5, so that means I did this right. So my final factored form would be 5, don't forget that common factor, a plus 5, and 7a plus 1. And then I'm going to set those equal to 0 and solve. So I would get a equals negative 5, or a equals negative 1 over 7 if I solve both of those equations. Okay. Looking at number 17, this is actually a special case of factoring because there is no c term. So start the same way we always do. Look for your common factor. So our common factor here is 2p. And then that would leave us with 3p plus 10. And this is actually the factored form. Then if we set each of these equal to 0, so if I set 2p equal to 0, I would get p equals 0. If I set 3p plus 10 equal to 0, I would get negative 10 thirds. So that's my factored form and the zeros. It always seems like it's a harder case, but it's actually the easiest case. Looking at number 18, we're going to start by taking out the common factor of 5. So it leaves us with x squared minus 5x minus 24. And if you look, this is the first one we've come across where a is 1 after we take out the common factor. So I'm going to actually use the shortcut on this one. So numbers that multiply to a times c, which is negative 24, and add to your middle number negative 5, negative 8, and 3 would work for that. So the shortcut, as a reminder, means that we can go straight to our factored form. Our first number was negative 8. Our second number was positive 3. And again, we can only do that because a was 1 in this quadratic. If I set these equal to 0 and solve, I get x equals 8 and x equals negative 3. Continuing with some factoring practice, looking for a common factor. I do believe there's a common factor of 4 here. So that would leave me with x squared minus 13x plus 40. And then we're going to look for numbers that multiply to a times c, which is 40, and add to negative 13, which is the b value. And negative 8 and 5, negative 5 should work. Again, a is 1, so we can go to the shortcut. So 4 on the outside for the common factor. Our numbers were negative 8, so x minus 8, and negative 5, so x minus 5. And then set each factor equal to 0 and solve. So hopefully this process is becoming a little bit quicker. If you're able to recognize that shortcut, make sure you're taking it. It's just going to make your life so much easier. No common factor here, but a is 1, so we're going to go straight into factoring and take the shortcut. This is best case scenario. So numbers that multiply to negative 24 and add to 2, 6 and negative 4. Because a is 1, we can go to the factored form. So we had positive 6 and negative 4. So n equals negative 6 or positive 4. All right, moving on to our second factoring target, which is target 7. Factoring and solving the difference of squares. So first thing we look for, just like before, is the common factor if we have one. So this one has a common factor of 3. And then as a reminder, the 3 things we look for in the difference of squares. We have to have 2 perfect squares. N squared and 9 are both perfect squares. They have to be subtracting, and b has to be 0, meaning there is no b term. So it meets all of that criteria. So then we take the square root of both of those numbers. So the square root of n squared is n, square root of 9 is 3. And then for the factored form, that's my common factor, I add those 2 values and I subtract them. And then just like before, I set each one equal to 0 and solve. Factored form and zeros solutions are both part of my final answer. I don't have a common factor over here on 22, so I'm going to go straight into square rooting both of them. And I do always check to make sure it is the difference of squares first before I actually do this. So this square root would be 2p, this would be 1. So the factored form, we're going to add those numbers, and then we're going to subtract them. Then I'm going to set each equal to 0 and solve. So I get p equals negative 1/2 and positive 1/2. All right, so on 23 and 24, we are going to graph in vertex form. So I'm going to start by finding the vertex, since it is in vertex form, and that's something that I will have to find. So the vertex is at negative 3, 4. This is always the x coordinate. You switch it. That's the y coordinate. So I'm going to go ahead and graph negative 3, 4. And if you think about your 1, 3, 5, 7 pattern, it gets multiplied by -2 here since the -2 is out in front. So it's actually a -2, -6, -10, -14 pattern. So I'm going to go down 2 over 1. And I'm going to go down 6 over 1. So 1, 2, 3, 4, 5, 6. And I'm going to go ahead and connect those points. And then there's some other information we need to be able to find. So we're going to find the intercepts. So starting with the x-intercepts. So in order to do this, and we can't see them on our graph, we know it's going to be some decimal. So I'm going to set y equal to 0. And now I'm going to solve for x. So I'm going to start by subtracting that 4 over. And then I'm going to divide by -2. So that gives me 2. Then I'm going to take the square root to get rid of that. So that would be plus or minus square root of 2. That doesn't simplify. And then I'm going to subtract this 3 over. So my x-intercepts would be -3 plus square root of 2, 0, and -3 minus square root of 2, 0. And if I needed that for my actual graph, I could plug that into a calculator to see what decimals they are. But for the sake of giving me an answer, you want to make sure to make that accurate and exact like we did there. For the y-intercept, we plug in 0 for x. So we have y equals -2, 0 plus 3 squared plus 4. And so that would be 9 times -2 is -18. That would be -14. But we're going to write that as a point. So 0, -14. And that doesn't help us with our graph because that's off the graph. And then we have our domain and our range. Domain of a quadratic is going to be all real numbers. The range, this opens downwards, so we're going to say y is less than or equal to, and the y value of your vertex is 4. So you have your graph and all the information you needed to find. On 24, we're going to start by finding the vertex. So using that same pattern, you have the vertex is -1, 1. And so -1, 1. And then think about your 1, 3, 5, 7 pattern here. There's a -1 out in front, so we're just going to multiply all that by a -1. So that just means we're going to go down 1 over 1. Down 3, 1, 2, 3 over 1. And this will be our quadratic. So next thing we found were the x-intercepts. And here we can actually just observe them based on our graph. So we don't have to solve for them unless you're really dying to. So -2, 0, and 0, 0. The y-intercept we can also just observe from our graph. It's at 0, 0. And then we need to find our domain, which we know all quadratics have a domain of all real numbers. And the range, since it opens down again, it's going to be y is less than or equal to, and then that y value of the vertex is 1. So that's your vertex form graphs. And then we move on to your standard form graphs here on targets 9, and then 11 is just all the information we find about it. So let's go ahead and find your vertex first. So to find your vertex, we're going to do x equals -b over 2a. So that would be -4 over 2, which is -2. So that gives you the x coordinate to your vertex, and you can plug that into your calculator to figure out what the y coordinate is going to be. And I'm getting -1. So -2, -1. And then the a value is 1, so this just follows the 1, 3, 5, 7 pattern. And that's helpful to graph first on this one just because then we can actually see what the x-intercepts are and stuff like that. So here's the vertex, don't lose that. The x-intercepts we can see from your graph are at -3, 0 and -1, 0. Your y-intercept we can see on your graph is at 0, 3. And then we can write your domain and range. So the domain of all quadratics is all real numbers. And the range of this one, because it's opening up, is going to be y is greater than or equal to, that y value is -1. Taking a look at 26, I'm going to start off the same way, finding the vertex. So we're going to do x equals -b over 2a, which would be -12 over -4, which is 3. So the vertex is at 3 something, and so you can plug in, and I'm just using a calculator to plug that into the original quadratic in for x. And my y value is 2. So 3, 2. And then if you think about your 1, 3, 5, 7 pattern and multiply it by -2, since that's the leading coefficient, you're going to go down 2 over 1 and then down 6 over 1. So just using that pattern to help me. And what's so nice about this is that when you look at your graph, then you have a lot of the information that you're asked to solve for, and you don't need to use quadratic formula or factoring or anything like that. So the x-intercepts here are 2, 0 and 4, 0. The y-intercept I actually can't see on this graph, so I am going to have to plug in a 0 for x, and I'm doing that into that original equation. And if I put that in my calculator, I just solve, I get -16. So that would be 0, -16, which is not on the graph. Makes sense because I can't see it. The domain of any quadratic is all real numbers. And then the range, since it's opening downwards again, is going to be y is less than or equal to, and the y value of that vertex is 2. Moving on to these last two problems, we have intercept form, which is actually my favorite. So for intercept form, we can actually start with the x-intercepts. It's always an easy way to start. It's whatever the zeros are. So this would be -4, 0 and -2, 0. So I'm going to graph those. And then for your vertex is going to fall right in between those two. And so the x value in between those two is -3. And I can plug in a -3 for x into the original equation, and I get out a 1. And this is making sense because I have a -1 out in front. So this means I'm doing the 1, 3, 5, 7 pattern, but just going downwards instead. So I know I'm going to go down 3 next, and then I'm going to go down 5. So I've built that graph, but then I have to find the rest of the information. So I have the x-intercepts, the vertex, I need the y-intercept, and I can see that on my graph. It's down there at 0, -8. And then the domain is all real numbers. This graph is opening downwards. So we're going to do y is less than or equal to 1, that y value of the vertex. Starting with the x-intercepts again on 28, since it's in intercept form. So if I set 2x equal to 0 and solve, I get 0, 0. And then the second one would be 2, 0. So just thinking about the zeros like I would when I'm solving. So the y value right in between those, the x value is right in between there is 1. So your vertex is going to be at 1 something, so we can plug in a 1, and then we should get out a negative 1, because that would be, oh no, sorry, we should get out a negative 2. That was my fault. And then if you think about your 1, 3, 5, 7 pattern, so this is over 1 up 2, because we're multiplying by 2 since there's a 2 out in front. So the next move would be up 6 over 1. And then finding the rest of the information, we need to find the y-intercept, which we can see on the graph is at 0, 0. The domain is all real numbers. The range is anything greater than or equal to negative 2. And that is your test review, your last test review before your final. Good luck.